Welcome to the deep dive. Today we're getting into hot work, stuff like welding, cutting, basically any job with an ignition source near flammable materials.
Right. And it sounds straightforward, but, quick jobs in places not really set up for it. That's a major fire risk.
Exactly. So we've looked through some training workshop materials. Our mission today is to really pull out the key bits for understanding these risks and, importantly, how to manage them.
It's crucial to get that definition right. Hot work isn't just like extreme heat. It's the combination heat plus nearby fuel. That's the hazard profile.
Good point. Let's kick off with electric arc welding. Super common method, right? Uses electricity to melt a wire and join metals.
Yeah, think of a controlled short circuit. You've got the welding machine, basically a transformer with positive and negative cables. That creates an electric arc.
And that arc melts the welding wire, the filler material, fusing the metal parts. We're talking serious heat, up to 4,000 degrees Celsius.
Which naturally brings hazards. Fire is the big one, obviously. But also welding, fumes, UV radiation, that arc flash can really mess up your eyes.
Yeah, flash burn. Nasty. Plus sparks, splatter, the electricity itself, and even just tripping over cables and gear.
And there are different flavors of arc welding. Shielded metal arc welding, SMAW, people often call it stick welding. That uses an electrode, a rod, coated with flux.
Right, and that coating does a few things, doesn't it?
It does. As it burns, it releases shielding gases to protect the molten weld pool from the air, creates a protective slag layer, and it also provides the filler metal as the electrode melts.
Pretty clever. What are the pros and cons?
Well, it's super versatile. You can use it indoors, outdoors, in pretty much any position, even tight spots. The gear's relatively portable too, and there's a huge variety of electrodes for different metals. But it's not the fastest process. You have to stop and change electrodes pretty often, and then you've got to chip off that slag afterward.
Okay, makes sense. So, safety precautions for electric welding. What are the key things?
Keeping cables up high, off the floor is a good start. Prevents damage and trips. Always check your power source and grounding. Grounding is vital.
Why is grounding so critical?
It gives any stray electricity a safe path to the earth, preventing the welder or the workpiece from becoming live and shocking someone. Also, never refuel a diesel welder while it's running or hot. Obvious, maybe, but crucial.
Right, and don't adjust the current while actively welding. Keep the grounding point close to the work. Inspect everything, cables, connections, insulation. Use the right cables. Don't bend them sharply.
Ground the machine itself. Clear away anything flammable within, 35 feet. Or use fire blankets if you can't move it. Good ventilation is key for fumes.
No dodgy extension cords either. And that fire watch.
Essential. Someone watching for sparks during the work and for at least 30 minutes after. Sparks can smolder for ages before erupting. That 35-foot radius isn't random. It's about how far sparks can fly.
Got it. Okay, let's switch gears slightly. Argon welding. Still electric, right?
Still electric, yeah. But this time you're using argon gas flowing from the torch to shield the arc and the weld puddle.
So, gas-shielded arc welding. TIG welding often uses this.
TIG, tungsten inert gas, is a common type, yes. You have an arc between the workpiece and an electrode, which might be non-consumable, like tungsten in TIG, or consumable, like in MIG welding. The argon protects everything. Sometimes you add filler wire. Sometimes you just fuse the base metals.
And argon itself, it's just a gas.
It's a noble gas. Colorless, odorless, chemically inert, meaning it doesn't really react with anything. It's actually the most abundant noble gas on Earth.
So why use it in welding?
That inertness is perfect for shielding. It stops the molten metal reacting with oxygen or nitrogen in the air, which would weaken the weld, prevents oxidation, reduces smoke. It's also used in light bulbs, funnily enough.
Okay. Any downsides or specific benefits?
It's denser than helium or air, so it provides good coverage even at lower flow rates, and it's less likely to get blown away. Gives a quieter, softer arc, too. Great for thin metals and works well with AC for welding aluminum, generally cost-effective and readily available in cylinders.
Hazards sound similar, though. Fire, fumes, UV, sparks, electricity, trips.
Pretty much the same core group. But yeah, you do need to be aware of specific metal fumes depending on what you're welding. Beryllium, cadmium, lead, nickel, zinc can be nasty. And dust like silica if there's grinding involved that can lead to silicosis.
And the specific argon safety point.
Those gas cylinders. Always keep them upright, secured with chains on a proper wheeled trolley or stand. Never let them fall over.
Right. Cylinder safety is huge. Okay, next up. Oxyacetylene. This is different, right? Uses a flame.
Totally different energy source.
Ah.
Here, you're burning acetylene gas mixed with oxygen to create a very hot flame, which you use to melt a filler wire.
So 2 cylinders, acetylene and oxygen regulators, hoses, and a torch.
Yep. High-pressure gases are reduced by regulators, travel through hoses, typically red for acetylene, green for oxygen mixed in the torch, and ignite at the tip.
Now, you mentioned something critical about acetylene pressure.
Absolutely vital. Acetylene working pressure must not exceed 15 psi. Above that, it becomes incredibly unstable and can decompose explosively even without air.
Wow. Okay. That's significant. How do they even store it safely then?
It's dissolved in acetone, which is held within a porous mass inside the cylinder. Acetone can absorb huge amounts of acetylene safely under pressure. Very clever engineering.
And storage rules. Oxygen needs to be kept away.
Definitely. Store oxygen cylinders at least 20 feet away from acetylene or other flammable gases, or separate them with a fire-resistant barrier at least 5 feet high with a half-hour fire rating.
Hazards for oxyacetylene, besides the obvious flame.
Fire and explosions are top risks due to the flammable gases. Also fumes, UV from the flame, splatter, direct contact with the flame, electricity if other tools are around, and tripping hazards again.
Safety checks.
Check for gas leaks with soapy water never aflame. Protect cylinders from bumps, keep them secured on trolleys. No oil or grease near oxygen fittings, especially it can react violently. Store cylinders properly, shaded if possible. Inspect hoses and regulators regularly. And crucially, use flashback arresters.
Flashback arresters, what do they do?
They're safety devices, usually fitted near the regulators or torch. They stop a flame from burning back up the hose and into the cylinder if something goes wrong. Absolutely essential. Also, clear flammables, have your firewatch, extinguisher, fire blanket ready.
And specific storage again.
Separate stores for acetylene and oxygen if possible. Well-ventilated spaces with high and low vents. Always store acetylene cylinders upright and secured.
Okay, moving on to cutting works. Angle grinders seem pretty common.
Very common. Used for cutting, grinding, polishing, cleaning. Powerful tools.
Hazards.
Fire from sparks, obviously. But also severe injuries if the wheel shatters or if you lose control. Face and body injuries are common. Sparks, electricity.
So inspection is key before using one.
Absolutely. Check the cable, make sure the body is insulated, the safety lock works, you've got the auxiliary handle fitted, and crucially, the wheel guard is in place and adjusted correctly. That guard deflects debris and contains fragments if the wheel breaks.
And the wheel itself.
Check it's the right type and size for the grinder, rated for the grinder's RPM, not expired, stored correctly, and shows no signs of damage like cracks or chips. A damaged wheel is a bomb waiting to go off. We've probably all seen pictures of disintegrated discs.
Yeah, scary stuff. And you can also cut with a torch, right? Similar to the welding.
Exactly. Oxyfuel cutting uses acetylene and oxygen to create a flame that preheats the metal, then a jet of pure oxygen burns through it. Procedures and inspections are very similar to oxyacetylene welding.
Right. Finally, let's talk about managing all this. Hot work plans and management programs. Sounds formal.
It needs to be. A written plan is usually required. It outlines who's in charge, who issues permits, who's authorized to do the work, what safety gear is needed, how the fire watch is organized, site-specific risks, the whole 9 yards.
Can contractors just use their own plan?
Often, yes, provided it meets the facility standards or regulatory requirements. The key elements of a good management program include clear policies where and when hot work is allowed, who authorizes it, who performs it, who monitors it, and detailed procedures. How to assess the area beforehand, how to prep it, how to handle particularly hazardous zones, what tools are required, and, critically, the permit to work process.
Training is huge too, I bet.
Essential. Everyone involved needs training relevant to their role. The workers, supervisors, the permit issuers, the fire watch. And communication, clearly posting procedures, policies, and identifying areas where hot work is flat out prohibited.
So the hot work permit itself, what does that really do?
It's a formal confirmation that the specific work area and the surrounding areas potentially affected by sparks or heat have been inspected and made safe before work starts. It acts as a checklist and an authorization.
And you mentioned reinspection.
Yes. Typically 30 minutes after the work is finished. That final check to ensure no smoldering fires have started.
What are some key pre-work checks on that permit list?
Things like confirming sprinklers are functional, checking the cutting welding gear is in good condition, ensuring floors are clear to flammables or wetted down covered. That 35-foot rule for flammables, move them or protect them, covering any openings or holes within that radius where sparks could fall.
What about working overhead or near walls?
Use drop cloths below overhead work. Ensure walls and ceilings are non-flammable or protected. Check the other side of walls or partitions heat can conduct through. Remove flammables from there too.
And confined spaces.
Whole other level. Needs cleaning, atmospheric testing for oxygen levels and flammable gases. LEL, lower explosive limit. Specific confined space entry permits. Continuous monitoring maybe.
Plus, ensuring lines or tanks are cleaned, purged, depressurized, isolated, lockout, tag out. Then notifying people in adjacent areas, having a fire extinguisher right there, proper PPE, always.
Using protective screens or barriers is important too, both for containing sparks and protecting others from UV radiation.
And the permit validity, it's not forever, right?
No way. It's usually just for that specific job or until the end of the shift day. If the job runs longer or conditions change, you need a new permit or reauthorization.
Okay, so wrapping up. It's clear hot work, whether welding or cutting, carries significant risks that need serious respect.
Absolutely. Even those just take a second jobs require proper planning and precautions. Understanding the specific method, the environment, and strictly adhering to safety protocols like permits and fire watches is non-negotiable.
Right. So thinking about everything we've discussed, all the different methods, the detailed procedures, what do you think is the most common shortcut or maybe the most overlooked safety step that leads to incidents? Where does complacency creep in the most?
That's a tough one, but I suspect it's often that 35-foot rule and the thoroughness of clearing or protecting everything within it, or maybe skipping the fire watch for a quick job. People underestimate how far a spark can travel or how long something can smolder. Getting that fundamental understanding that even a tiny spark is a potential disaster in the wrong place truly embedded seems key to preventing incidents across all kinds of work environments.